This is solving one-step equations part 2. We went more in depth in part 1. This is 10 more examples if you need additional help. For example, we're going to do 10 more examples here. And we're solving for x. We're going to divide both sides by -12 to isolate x. And when you divide, you get x equals 8. When you divide two negatives, you get a positive. This would actually be 1 times x, which is x. So our solution set is 8. In this case, the opposite of +4 is -4. So to isolate m, we subtract 4 to use our zero property. And subtract, you get m equals -15. So our solution set is -15. And this would be considered number 2. So we're going to do 8 more. Number 3, we have -3v equals 24. There's nothing to add or subtract, so we're going to divide both sides by -3. And the -3's cancel here, so we get v equals -8. So our solution set is -8. Number 4, we have 8n equals 80. On these, I like the students to try to do this in their head, mentally. Can you tell me 8, remember you've done this before, 8 times what equals 80? 80 times what number equals 80? And if you can do this in your head, that's actually better. So if you know the answer is 10, then your n in this case equals 10. Or you could do like we've been doing and divide both sides by 8, and you get n equals 10, because that would cancel and this equals 10 here. So our solution set is 10. Number 5, we have -3 minus x equals -1. Now in this case, this one's not so easy to do in your head. So we're going to go ahead and use PEMDAS backwards, which works a lot of times. Is there anything we could add or subtract at both sides to help isolate x? Well, we can add, since this is a -3 here, we can add 3 to both sides. And what we get is -x equals 2, -1 plus 3. Or you could say 3 minus 1 is 2. You can go the other way. Now we're solving for x, not -x. And before, what I did is, since this is multiplying by -1, I'm going to do something a little different here. What I'm going to do is, when you see something like this, I'm just going to negate the whole equation. And when you negate the whole equation, that means you're multiplying by -1. And I'm going to look at it, it's a distributive property, which we'll see in the next video we do. But what I'm going to do when I negate it, I'm going to take away this 1 here. Just think of it as negating. And what we're going to do is the opposite of -x is positive x. The opposite of +2 here is -2. So that's what I would call negating the equation. You just make all the signs opposite of what they are. And that's another technique. Okay, number 6, we have 5/3 x equals 20/9. Now in this case, it's always just multiply both sides by the reciprocal, which is the reciprocal of what constant is in front of the x. So in this case, our constant is 5/3. So I'm going to multiply both sides by 3/5. Because this would be 15/15, which is 1. 15/15 equals 1. That cancels, and you're left with x. Then you multiply this side. You can multiply across, which would be 60 over 45, and reduce that way. Or you could just say, I'm going to do it over here, 20 over 9 times 3/5. What I'm going to do is say 3 goes into 9 3 times, and 5 goes into 20 4 times. So you get 4/3. Either way, whatever works for you. We like to do it this way a lot if you can't use a calculator, because this way here is a little harder. Okay, number 7. We have r minus a negative 3 equals 16 over 9. Now, in this case, we're starting to see the parentheses. And before we do anything, I want to get rid of the parentheses because they're really confusing to look at. We're going to see more of this in the next video. But to get rid of the parentheses, let's just note that this is like saying, either you can say this is -1 times -3. So we're having to simplify before we solve. And that means when we're simplifying, we're using PEMDAS. So -1 times -3 is +3. So that would be r plus 3 equals 16 over 9. Or you could do it this way. Take away the negative. Okay, let me rewrite this. And this negative just means negate the -3. And that would give you +3. Now what we're going to do is subtract 3 from both sides. And I'm going to do it horizontally on this one instead of vertically. So what I'm going to do is subtract 3 from both sides. In this case, we'll get r, because 3 minus 3 is 0. So we get r. In this case, we have 16 over 9 minus 3. And you can't subtract without having the same common denominator. So to have the same common denominator, we're going to have 9 here. And you're going to ask yourself, what times 1 is 9? And it's 9. 9 times 3 is 27. Then you go ahead and subtract, and you're going to get -11 over 9. And we're going to write this as a solution set. Okay, the next one is -84 equals 4v. And this one seems pretty easy. You just divide both sides by 4. Now, unless you can do it in your head and say what number times 4 is -84, which is basically what you're doing anyway. So when you divide, you get v equals -21. All I did is say 4 goes into 8 2 times, 4 goes into 4 1 time. So my solution set is -21, 8. We have, or this was 9 actually. This was 8. This is 9. We have -17 equals 8 over 26. This case, the x is on the right-hand side like our v was. And basically, you're multiplying both sides by 26 over 1. Multiply both sides by 26 over 1. This cancels, and x times 1 is x. And 26 times -17 is -442. And the last one has one of these parentheses again. We have x plus and negative 15 equals negative 43. I want to get rid of this parentheses here. And basically, we could write it this way. You might have seen this before. But anytime you see something like that, that means it's a negative. So we're going to say x minus 15 equals negative 43. And you add 15 to both sides. And you're going to get x equals negative 28. Or a solution set is negative 28. I want to make a note about this. Negative and minus. So you can say x plus a negative 15 versus x minus a 15. And I just want you to know they both mean take away. And if you say to yourself take away, I think it helps. So you can say x and you take away 15, or you can just say x take away 15. And I think that will help later on when we do the next video, which is solving multi-step equations.